Hello. Hello and welcome to this video on going through documentation of Python 3.14.7, and we had read through weakref. Now we will go through types, which is about dynamic type creation and names for built-in types. So it might take, let's say, you might take 2 videos. Okay. So let's see. Now, once we are done with types, we will move on to copy. Okay. So without further ado, let's get started. The example will come after the theory part. So stay tuned for theory and we will see the example after this. So let's go through the documentation. This module defines utility functions to assist in dynamic creation of types. It also defines names for some object types that are used by the standard Python interpreter, but not exposed as built-ins like int or str. Finally, it provides some additional type-related utility classes and functions that are not fundamental enough to be built-ins. So we have dynamic type creation, we have types.new class, takes names, tuple of bases, keywords, exec body, and so on. Creates a class object dynamically using the appropriate meta class. As far as I remember, we have not discussed meta classes. So we'll see meta classes all the way at the end. So for now, just remember this. The first 3 arguments are the components that make up a class definition header. The class name, the base classes in order, and keyword arguments such as meta class. The exec body argument is a callback that is used to populate the freshly created class namespace. It should accept the class namespace as its sole argument and update the namespace directly with the class contents. If no callback is provided, it has the same effect as passing in lambda ns colon none. Then we have types.prepare class, takes name, bases, and keywords. Calculate the appropriate meta class and creates the class namespace. The arguments are the components that make up a class definition header, the class name, the base classes in order, and the keyword arguments such as meta class. The return value is a 3-tuple. Master class, meta class, namespace, and keywords. Meta class is the appropriate meta class, namespace is the prepared class namespace, and keywords is an updated copy of the passed in keywords arguments with any meta class entries removed. If no keywords argument is passed in, this will be an empty dictionary. So meta classes is, we'll see after this video, meta classes. Full details of the classification process supported by these functions. And then we have PEP, which talks about meta classes in Python 3000. Then we have types.resolve bases, which takes bases. Resolve MRO entries dynamically as specified by PEP 560. This function looks for items in bases that are not instances of type and returns a tuple where each such object that has an MRO entries method is replaced with an unpacked result of calling this method. If basis item is an instance of type or it does not have an MRO entries method, then it is included in the return tuple unchanged. Then we have get original basis, which takes a class. Return the tuple of objects originally given as the basis of CRS before the MRO entries method that has been called on any basis, following the mechanism laid out in PEP 560. This is useful for introspecting generics. For classes that have an orig_basis attribute, this function returns the value of cls.origBasis. For classes without the orig_basis attribute, cls.basis is returned. So we have examples here. So from typing is another module which we will discuss. We import type where generic name tuple and type dict. From the type where we create T, and then from this type T, we create several classes. So for example, there could be class foo with generic T, and then we have bar with foo of int float. Then we have baz with list of str. Then we create a name tuple eggs which has a comma int b comma str as the numbers. Then we have spam which creates a type dict spam where a is integer, b is str. Now from this we assert that the basis of bar is foo comma float, and when we apply get original basis on bar we get foo int comma float. Similarly, badge has the basis of list, and original basis contain list str. Similarly, the basis of eggs is a tuple, and get original basis of eggs will give us name tuple, and the basis of spam is a dict, and original basis is type dict, and the inbuilt int has basis object, and original basis is also object. So PEP 560 is core support for typing module and generic types. Now we have standard interpreter types. This module provides names for many of the types that are required to implement a Python interpreter. It deliberately avoids including some of the types that arise only incidentally during processing, such as the list iterator type. Typical uses of those names is for is instance or is subclass checks. If you instantiate any of these types, note that signatures may vary between Python versions. Standard names are defined for the following types. The types.none type is the type of none, function type or lambda type, the type of user-defined functions and functions created by lambda expression, ranges and auditing event function.new with argument code. The audit event only occurs for direct instantiation of function objects and is not ready for normal compilation. Then we have generator type, the type of generator iterator objects created by generator functions. Then we have coroutine type, the type of coroutine objects created by async def functions. Now this will require a lot of explanation. Coroutines and async def if you are new to programming. So just know that it is some sort of function, okay? Then we have async generator type, the type of asynchronous generator iterator objects created by a synchronous generator function. Then we have code type, which take EW arguments, the type of code objects such as returned by compile. Ranges and auditing event, code.new with argument codes, file name, comma name, comma r count, comma position, pass only r count, comma keyword only r count, comma number of locals, comma stack size, comma flags. Note that the audit arguments may not match the names or positions required by the initializer. The audit event only occurs for direct instantiation of code objects and is not raised for normal compilation. Then we have cell type, the type for cell objects. Such objects are used as containers for a function's closure variables. Then we have method type, the type of methods of user-defined class instances. We have built-in function type or built-in method type, the type of built-in functions like len or sys.exit or methods of built-in classes. Here the term built-in means written in C. Then we have wrapper descriptor type, the type of methods of some built-in data types and base classes such as object underscore init underscore or object dot less than. Then we have method wrapper type, the type of bound methods of some built-in data types and base classes. For example, it is the type of object.str. Then we have not implemented type, which is the type of not implemented. Method descriptor type, the type of methods of some built-in data types such as str.join. We have class method descriptor type, the type of unbound class methods of some built-in data types such as dict.__dict_from keys. Then we have module type, which takes an argument name and that is none, the type of modules. The constructor takes the name of the module to be created and optionally its docstring. So we have, we can, you can also go for documentation on module objects and see what is there, or import lib.util.module from spec. Modules created using the module type constructor are created with many of the special attributes on set or set to default values. Module from spec provides a more robust way of creating module type instances, which ensures the various attributes are set properly. Then we have Alexis type, which is the type of Alexis. We have generic alias, which takes t underscore origin and t underscore args. The type of parameterized generic such as listen. T underscore origin should be a non-parameterized generic class such as list, tuple, or dict. T underscore arg should be a tuple, possibly of length 1, of types which parameterize T underscore origin. So for example, you can import some types, import generic alias, and you can create a list of integers like generic alias list command, and you can create a dictionary of str command with generic alias dict str command. So these we will see quite a lot, the generic aliases. Okay. So we have in-depth documentation for types.generic alias and 585 for type hunting generics in standard collections. Don't worry that we are skipping this. Eventually, we will go through all of PEP. Okay. PEPs are what governs the entire Python stuff. So we'll eventually go through the PEPs. So if you are watching the playlist in order, then you would know what PEPs are. Okay. Then we have union type with the type of union type expressions. We have not yet gone through typing modules, so we have not yet covered the union type. Then we have traceback type, tb underscore next, tb underscore prime, tb underscore last I, tb underscore line number. The type of traceback objects such as found in sys.exception.traceback. See the language reference for details of available attributes and operation and guidance on creating traceback demonstrated. I don't think we will go and read language reference. It's just too much. Okay. Then we have frame type, the type of frame objects such as found in tb.tb underscore frame if tb is a traceback object. We have set descriptor type, the type of objects defined in extension modules with get-set ref such as frame type dot f underscore locals or array dot type code. This type is used as descriptor for object attributes. It has the same purpose as a property type, but for classes defined in extension modules. Then we have member descriptor type, the type of objects defined in extension modules with member f, such as datetime.timeDelta.place. This type is used as a descriptor for simple C data members, which use standard conversion functions. It has the same purpose as a property type, but for classes defined in extension modules. In addition, when a class is defined with the slots attributes, then for each slot, an instance of member descriptor type will be added as an attribute of the class. This allows the slot to appear in the classes step. See Python implementation detail. In other implementations of Python, this type may be identical to getSet descriptor type. We have mapping proxy type, which takes a mapping, read-only proxy of a mapping. It provides a dynamic view on the mapping entries, which means that when the mapping changes, the view reflects those changes. Mapping proxy types are generic over two types, signifying that respectively the types of the underlying mappings, key and values. Then we have key in proxy, return true if the underlying mapping has a key, or key as false. Then we have proxy with key, return the item of the underlying mapping key, raises key error if key is not in the underlying mapping. Proxy returns an iterator over the keys of the underlying mapping. This is a shortcut for iter proxy.keys. We have line proxy, return the number of items in the underlying mapping. We have copy, return a shallow copy of the underlying mapping. We have get key comma default, return the value for key if key is in the underlying mapping, it's default. If default is not given, it defaults to null so that the method never raises a key error. Items return a new view of the underlying mapping items key value pairs. Keys return a new view of the underlying mapping keys. Values return a new view of the underlying mapping's values. Reversed return a reverse operator over the keys of the underlying mapping, and hash return a hash of underlying mapping. And finally, we have capsule type, which is the type of capsule objects. Additional utility classes and function, we have simple namespace, a simple object subclass that provides attribute access to its namespace as well as a meaningful wrap. Unlike object with simple namespace, you can add and remove attributes. Simple namespace objects may be initialized in the same way as it, either with keyword arguments, with a single positional argument, or with both. When initialized with keyword arguments, those are directly added to the underlying namespace. Alternatively, when initialized with a positional argument, the underlying namespace will be updated with key value pairs from that argument. Either a mapping object or an iterable object producing key value pairs, all such keys must be strings. The type is roughly equivalent to the following code, so I will not go into this. Should we go into this? Okay, it is complicated, looks complicated at least. Okay, so you have this class name, simple namespace. This is the constructor. So it will take either a mapping or an iterable. Okay, and keywords as well. So it has an attribute, private attribute dictionary, which will be updated by the mapping or key iterable, and it also updates with the keywords. This is the repr function used to represent the string format of the namespace. Then we have equality function, operator overloaded. It will compare this namespace with another namespace. So the name, when you take the is instance of self, it should be simple namespace, and the other argument should also be of an instance of simple namespace. And then it will compare the dictionaries, the dict modules of the self and other. Now, if both are not of simple namespace type, that is, both are not instances of simple namespace, then it will be a not implemented exception. Simple namespace may be useful as a replacement for class ns::pass. However, for a structured record type, use name tuple instead. Simple namespace objects are supported by copy.replace. Then we have types.dynamic class attribute, which is fget none, fset none, fdel none, dot none. Route attribute access on a class to get attribute. This is a descriptor used to define attributes that act differently when accessed through an instance and through a class. Instance access remains normal, but access to an attribute through class will be routed with the class's get attribute method. This is done by raising attribute error. This allows one to have properties active on an instance and have virtual attributes on the class with the same name, see enum.enum for an example. And finally, we have coroutine utility functions. So we have types.coroutine, which takes a genfunc. This function transforms a generator function into a coroutine function, which returns a generator-based coroutine. The generator-based coroutine is still a generator iterator, but is also considered to be a coroutine object and is awaitable. However, it may not necessarily implement the await method. If genfunc is a generated function, it will be modified in place. If genfunc is not a generated function, it will be wrapped. If it returns an instance of collections.abc.generator, the instance will be wrapped in an awaitable proxy object. All other types of objects will be returned as is. So here is some comment about this particular documentation. Some of it you will understand and some of it you might not have understood. For example, coroutines we have not discussed. They are very special stuff. Similarly, meta classes we did not touch. Okay, we have not yet studied meta classes. I don't remember that I discussed meta classes. Similarly, data classes and properties are not discussed. Now I have a choice that I can go through all these see also sections, but then you go into the rabbit hole. So we'll see, for example, if you look at meta classes, this would be in the language reference, I expect. Yep, language reference. So we will cover meta classes later on and some other aspects. Steps we will cover once we finish all the documentation. Steps I will not cover there will not be regular videos. One-off videos will be there on PEPs, and slowly we will go through the PEPs of the objective here is not to get all the knowledge of the or all the details which is available, but rather to be aware of what is there. Okay. So in the next video, I will show some examples, particularly of interest would be the generic alias examples. So the tapping module actually is of very much interest where this comes into picture. So for example, tapping module, when do we have tapping? Okay, so quite a bit at a distance, it'll be quite, we'll have to go through a lot of documentation before we do that. So in the next video, I will show you the example of types, and possibly we will go through copy module as well. Okay, it is quite small and we can finish this in one video along with example. So I hope that you are enjoying. I know that this documentation of types is quite advanced and it involves lots of other concepts. But I hope that you were able to learn something of value from this documentation and found it useful. So we will meet again after 4 days with another video on the example of types module. I will also include copy module examples and the documentation of copy module. Till then, stay curious, uh, keep learning, and most importantly, enjoy.